Picture a machine 40 feet wide capable of harvesting 7,200 bushels of corn per hour, enough to fill a semi-truck trailer in minutes. Imagine equipment so advanced it folds itself for transport without requiring specialized trailers, guided by sensors that follow crop rows with precision measured in inches. Most farmers would say that's the stuff of science fiction. Most farmers would be wrong. This is the story of the John Deere C16F folding corn head, a machine that redefined what's possible in modern corn harvesting. Born from decades of agricultural engineering evolution and designed specifically to match the capacity of John Deere's monstrous X-Series combines, this 16-row marvel represents the cutting edge of American farm technology. Here's the kicker. This isn't just bigger equipment for bigger farms. It's a fundamental reimagining of how American agriculture approaches one of its most critical tasks. And that's where the story begins. The C16F didn't emerge from a vacuum. Its origins trace back through generations of John Deere cornhead development, decades of incremental improvements that transformed harvesting from backbreaking manual labor into precision automated agriculture. To understand the C16F, you need to understand where corn harvesting started and how far it's come. In the early decades of the 20th century, corn harvest meant hand-picking ears from standing stalks, tossing them into wagons pulled by horses or early tractors. A good worker might harvest an acre per day in favorable conditions. That pace defined farming's seasonal rhythm. Long autumn days racing against first frost, entire communities mobilized for harvest, children missing school to help bring in crops before winter arrived. John Deere entered mechanical corn harvesting in the 1920s and 30s with pulled pickers that revolutionized the process, but still operated at relatively modest capacities. These early machines pulled ears from stalks mechanically, saving farmers from hand-picking while introducing new challenges around maintenance, adjustment, and keeping equipment running through long harvest days. The real transformation came with self-propelled combines in the post-World War II era, machines that not only picked corn, but also separated grain from cobs and deposited cleaned corn directly into grain tanks. Combines fundamentally changed harvest economics by eliminating multiple handling steps and allowing single operators to accomplish work that previously required crews. The evolution from 2-row pickers to 4-row heads to 8-row and 12-row configurations marked steady progress through the latter 20th century. Each capacity increase required solving new engineering challenges around power transmission, material handling, and structural integrity at larger scales. But combine evolution created new bottlenecks. As combine capacity increased through the 1960s, 70s, and 80s, corn heads struggled to keep pace. A combine capable of processing 10,000 bushels per hour was useless if its corn head could only gather 6,000 bushels hourly. The corn head became the limiting factor, the constraint that prevented farmers from realizing their expensive combine's full potential. John Deere engineers recognized this problem and dedicated themselves to developing corn heads that matched combine capacity while managing the unique challenges corn harvesting presents. Corn isn't like wheat or soybeans that combines harvest with simple cutter bar headers. Corn requires specialized equipment that can grab individual stalks, strip ears cleanly, process heavy residue, and feed material into the combine without plugging or damaging grain. The engineering challenge multiplies exponentially when designing equipment to harvest 16 rows simultaneously while maintaining the gathering efficiency and grain quality that farmers demand. Each row unit must operate independently, yet synchronously, with its neighbors, gathering stalks that vary wildly in diameter, height, and moisture content, while maintaining consistent feeding rates to the combine. The gathering chains that pull stalks downward must grip firmly enough to control plants, but gently enough to avoid shattering ears prematurely and losing grain before it reaches the snapping mechanism. Snapping rolls that break ears from stalks require precise spacing and timing. Too wide and ears slip through unharvested, too narrow, and they crush kernels or create excessive resistance that bogs down the entire header. The power transmission system must deliver hundreds of horsepower to 16 sets of gathering chains, snapping rolls, and chopping knives, while accommodating the shock loads that occur when the header encounters variations in crop density or hits obstacles. Hydraulic deck plates that control the gap between snapping rolls need continuous adjustment capability, so operators can optimized settings for changing stalk diameters as they move between corn hybrids or field zones with different growing conditions. The lateral auger system must handle not just corn ears, but also the inevitable cobs, husks, and stalk pieces that enter the system, moving this mixed material smoothly without creating jams that shut down harvesting operations. Maintaining consistent header height above the ground across 40 feet of width requires sophisticated sensing and hydraulic control that can react instantly to terrain changes, preventing the header from digging into soil or riding too high and missing low-hanging ears. The structural rigidity needed to prevent the header from flexing and distorting row spacing conflicts, with the need for enough flexibility to follow ground contours without transferring damaging shock loads to the combine feeder house. Engineers also had to solve the challenge of providing adequate operator visibility. Sitting in a combine cab 20 feet behind a 40-foot wide header makes judging the outer edges positions nearly impossible without cameras, mirrors, or other aids. The cumulative effect of these engineering challenges meant that developing a 16-row folding corn head capable of matching X series combined capacity required solving dozens of interconnected technical problems, where the solution to one often complicated others. The C16F emerged from John Deere's CF Series corn head development program, an initiative launched to create equipment specifically engineered for the X Series combines that John Deere introduced in the 2010s. The X Series represents John Deere's most advanced combine technology, featuring unprecedented grain tank capacities, processing power, and automation. The X9 1000 and X9 1100 combines can handle grain volumes that would overwhelm earlier machines. But that capacity creates a challenge. You need corn heads capable of feeding these mechanical monsters fast enough to keep them working efficiently. A 16-row corn head harvesting at capacity can gather over 7,000 bushels hourly in high-yielding corn, but only if it's engineered to handle the speed, residue volume, and operational demands that such productivity requires. John Deere's development teams spent years testing prototypes, gathering feedback from commercial farmers, and refining designs before releasing the CF series to the market. The investment in research and development reflected the company's commitment to maintaining its position as the dominant force in North American agricultural equipment manufacturing. John Deere's engineering teams faced multiple challenges developing the C16F. First, the physical scale. A 16-row corn head with 30-inch row spacing measures approximately 40 feet wide when fully deployed. That width creates obvious transport challenges. Conventional rigid corn heads that wide require specialized header trailers, adding expense and complexity to moving equipment between fields. The folding design that defines the C16F addresses this problem elegantly. Hydraulic cylinders fold the outer sections upward and inward, reducing transport width to approximately 20 feet, narrow enough to travel public roads legally in most states without special permits or pilot vehicles. This folding capability sounds simple, but represents sophisticated engineering. The corn head must fold and unfold quickly, reliably, and safely, while maintaining perfect alignment when deployed for harvesting. Operators can complete the entire folding sequence in minutes from the combine cab, eliminating the time-consuming process of disconnecting rigid headers and maneuvering them onto transport trailers. The time savings compound dramatically over a harvest season, when operators might move between fields multiple times daily, with each move previously requiring 30 minutes or more of manual labor and careful maneuvering. The folding mechanism incorporates multiple safety features that prevent accidental deployment during transport and ensure the corn head locks securely in both folded and unfolded positions. Hydraulic cylinders, powerful enough to lift thousands of pounds of steel machinery, must move smoothly and controllably, coordinated through electronic controls that sequence the folding process properly. The header's structure must be rigid enough when unfolded to maintain precise row spacing and gathering efficiency. Yet it must incorporate the articulation points necessary for folding without creating weak points that could fail under the tremendous forces generated during harvest. Every structural member, every pivot point, every hydraulic connection represents careful engineering, balancing competing demands for strength, flexibility, and reliability. The locking mechanisms that secure the header in unfolded position must engage positively and hold against forces exceeding tens of thousands of pounds as the header pulls against standing corn and processes tons of material hourly. John Deere engineers conducted extensive finite element analysis and physical stress testing to ensure the folding joints and locking systems would survive decades of operation under punishing field conditions. The result is a folding mechanism so robust and reliable that farmers quickly forget their operating equipment with articulated sections, trusting the engineering to maintain alignment and structural integrity harvest after harvest. Beyond the folding mechanism itself, the C16F incorporates technologies that transform corn harvesting efficiency. The Romax chopping stalk rolls represent one such innovation. Traditional corn heads used smooth or fluted gathering rolls that grabbed stalks and pulled them downward toward snapping plates that broke ears from stalks. Those gathering rolls left stalks relatively intact, creating bulky residue that had to be managed through tillage or time. The Romax system features intermeshing knife rolls, rotating cylinders covered with hardened steel blades that don't just pull stalks down, but actively chop them into pieces typically less than 6 inches long. This aggressive residue processing provides multiple benefits for modern farming practices. The knife rolls are precisely timed to intermesh without contact, creating a shearing action that slices through even the toughest corn stalks with minimal power consumption. The hardened steel construction withstands the abrasive effects of soil, sand, and silica naturally present in corn stalks, maintaining sharp cutting edges through hundreds of operating hours before requiring replacement or refurbishment. The intermeshing design means each knife blade passes between blades on the opposing roll, with clearances measured in fractions of an inch, creating scissor-like cutting action rather than relying on brute force to break stalks apart. John Deere engineers spent years optimizing the blade profile, angle, and spacing to maximize cutting efficiency while minimizing power requirements and component wear. The Romax system operates at precisely calculated rotational speeds that balance aggressive chopping action against the risk of wrapping or plugging when encountering wet or tangled stalks. Each set of knife rolls is driven independently through its own gearbox and chain drive system, allowing individual row units to handle varying stalk conditions without affecting neighboring units' performance. The chopping action occurs continuously as stalks pass through the rolls, with each stalk receiving multiple cuts that reduce it to the target 6-inch length before the material exits the row unit. Operators can monitor Romax performance through combine displays that show individual row unit loads, alerting them to potential plugging or excessive wear before problems escalate into costly breakdowns. The modular design of the knife roll assemblies allows relatively quick replacement in the field if damage occurs, with each unit bolting into standardized mounting points that ensure proper alignment and timing when new components are installed. Field testing demonstrated that the Romax system could process over 15 tons of corn stalks per hour per row unit, while maintaining consistent residue sizing, regardless of stalk moisture content ranging from 15% to over 40%. The improved residue distribution that Romax chopping provides creates more uniform field conditions for subsequent planting operations, eliminating the row-to-row variability that occurs when intact stalks accumulate unevenly behind conventional gathering systems. Agronomic research has shown that fields harvested with Romax chopping equipment experience faster spring warm-up and improved seedbed conditions because the smaller residue pieces allow better soil-to-sun contact and don't create insulating blankets of matted material. Chopped residue decomposes faster than intact stalks, returning nutrients to soil more quickly and reducing disease pressure from pathogens that overwinter in crop residue. Shorter residue interferes less with spring planting operations, particularly in no-till or minimum-till systems, where planters must cut through previous year's crop remains. The Romax knives handle high-moisture corn, stalks with moisture content exceeding 32% that would bog down or plug conventional gathering systems. Wet stalks that bend and wrap around smooth rolls shatter and chop efficiently when attacked by aggressive knife rolls, spinning at hundreds of revolutions per minute. The knife rolls transform tons of corn stalks hourly from challenging waste into manageable organic matter that improves soil health rather than creating problems. Agronomists have documented measurable improvements in soil organic matter content and microbial activity in fields where chopped residue is managed properly compared to fields where intact stalks accumulate and decompose slowly. The Romax system also reduces the stalk-borne diseases that plague continuous corn rotations by destroying the physical structure that fungal pathogens use for overwintering, breaking disease cycles that otherwise require crop rotation or fungicide applications to manage effectively. The C16F's auger system represents another critical advancement. Previous generation corn heads used relatively small diameter augers, typically 13 to 15 inches, to move gathered ears from row units toward the center of the header where they fed into the combine. Those augers struggled to handle the volume that 16-row heads gathering at high speeds produce. The C16F features an 18-inch diameter auger with increased torque capacity, specifically engineered to move massive quantities of corn rapidly and reliably. The larger diameter creates more capacity per revolution, while the increased torque ensures the auger continues turning even when handling slug loads. Sudden surges of material that can overwhelm undersized augers and cause plugging. The auger drive system incorporates slip clutches and overload protection that prevent catastrophic damage if foreign objects like rocks or fence posts enter the header, allowing the auger to stall momentarily rather than shearing driveline components that would require expensive repairs and extended downtime. The auger floor features rolled construction that creates a smooth transition between the auger flights and the floor surface, reducing kernel damage that occurs when ears get pinched between sharp auger edges and rough floors. Every damaged kernel represents lost revenue. Cracked or broken kernels downgrade corn quality and reduce value at delivery. The C16F's gentle handling preserves grain quality even when operating at maximum capacity, ensuring farmers receive top dollar for crops they've invested months growing. Active end fenders address another persistent corn harvesting challenge. The end dividers at each edge of the corn head must separate the rows being harvested from adjacent rows left standing. In perfect conditions with straight, evenly spaced rows, this works seamlessly, but real-world cornfields rarely offer perfect conditions. Down corn, stalks, knocked over by wind, rain, or hail, creates tangles where determining individual rows becomes nearly impossible. The active end fenders use hydraulically controlled paddles that can extend outward or retract inward, actively guiding lodged corn into the proper gathering chains, even when stalks are laying nearly horizontal. This active guidance prevents ear loss and reduces the plugging that occurs when tangled stalks wrap around stationary dividers. The hydraulic actuation system responds to operator commands from the combine cab, allowing real-time adjustment of fender position based on changing field conditions, without stopping to make manual adjustments. Sensors integrated into the active end fenders detect resistance when encountering heavy tangles or obstacles, automatically modulating hydraulic pressure to prevent damage while maintaining effective crop guidance. The paddles are constructed from durable polymer materials that provide the right combination of flexibility to deflect when hitting immovable objects and rigidity to guide crop effectively into gathering mechanisms. Traditional stationary end dividers often rode over lodged corn or pushed it down further into the soil, leaving ears unharvested and creating frustration for operators who could see grain being lost but had no way to recover it. The active end fenders eliminate this problem by actively lifting and feeding lodged stalks into the gathering chains, regardless of how severely they're laying down. In fields where summer storms have created patches of down corn interspersed with standing crop, operators can extend the fenders when entering damaged areas and retract them when returning to normal conditions, optimizing performance for each field zone. The system proves particularly valuable in fields planted with modern high-population hybrids that can reach plant densities exceeding 35,000 stalks per acre, creating thicker stands more susceptible to lodging under adverse weather conditions. The active end fenders also improve performance in terraced fields where row ends often terminate at angles or where turning at headlands creates irregular crop patterns that challenge conventional divider designs. John Deere engineers designed the fender mounting system to withstand the substantial side loads that occur when processing heavy volumes of lodged corn, using reinforced brackets and oversized pivot pins that prevent fatigue failures. The hydraulic cylinders that actuate the fenders incorporate position sensors that provide feedback to the combine's control system, ensuring operators always know the exact fender position and can return them to optimal settings quickly. Field experience has demonstrated that active end fenders can reduce harvest losses in lodged corn by 3 to 5% compared to conventional stationary dividers, translating to multiple bushels per acre saved in severely damaged fields. The financial impact of this loss reduction becomes significant across hundreds or thousands of acres, often recovering the cost of the active end fender option within a single challenging harvest season. Operators appreciate the active end fender's contribution to peace of mind, knowing they have tools to handle whatever field conditions nature throws at them, rather than accepting losses as inevitable. The technology represents John Deere's philosophy of providing farmers with solutions to real-world problems, rather than just incremental improvements to existing designs that work well only under ideal conditions. Winter testing programs conducted in Southern Hemisphere markets allowed John Deere engineers to validate active end fender performance across diverse crop conditions and farming practices before releasing the technology to North American customers. Stalk deflectors installed on every row unit provide another layer of operational refinement. These angled metal shields deflect cut stalks away from vulnerable mechanical components, reducing wear and preventing the accumulation of residue that can interfere with gathering chains and snapping mechanisms. The deflectors also help distribute chopped residue more evenly across the field behind the header, rather than leaving windrows of concentrated material that create problems during subsequent field operations. Factory installation ensures these deflectors are positioned optimally and integrated properly with other header components, rather than requiring aftermarket installation that might compromise performance. The integration of AutoTrack RowSense guidance technology represents the C16F's most sophisticated advancement. RowSense uses mechanical feelers mounted on row units that physically contact corn stalks, detecting the exact position of each row. This tactile feedback provides guidance information to the combine's steering system with accuracy impossible to achieve through GPS alone. GPS guidance works well in many applications, but struggles in corn harvesting, where following precise rows matters more than following predetermined paths. Rows aren't perfectly straight. Planting equipment may have drifted slightly. Terracing creates curved rows that no GPS path can follow accurately. RowSense solves these problems by continuously sensing actual row positions and adjusting the combine's steering to follow them exactly. The benefits extend beyond simple row following accuracy. In down corn, where visual identification of rows becomes nearly impossible, RowSense continues working by feeling stalks, even when operators can't see individual rows. On hillsides where combines tend to drift downhill, RowSense counteracts that drift by, keeping the header centered on rows despite terrain-induced steering forces. During night harvesting operations that have become increasingly common as farms grow larger and harvest windows compress, RowSense provides guidance accuracy that exhausted operators cannot maintain hour after hour. The system reduces operator fatigue dramatically, transforming harvesting from constant vigilance and steering corrections into monitoring automated systems that handle routine guidance, while operators focus on overall machine performance and field conditions. The RowSense feelers are positioned strategically on multiple row units across the header width, providing redundant sensing that ensures accurate guidance even if individual sensors encounter gaps in crop stand or damaged areas. The system's sophisticated algorithms filter out false signals from weeds, volunteer corn, or debris that might otherwise confuse simpler guidance technologies and cause erratic steering behavior. RowSense calculates the optimal steering correction dozens of times per second, making micro adjustments that keep the header precisely centered on rows, without the hunting and overcorrection that plague manual steering attempts. The technology proves especially valuable in fields with curved or contoured rows following terraces, waterways, or property boundaries, where GPS guidance following straight lines would result in significant crop damage and yield loss. Operators report that RowSense allows them to maintain higher ground speeds with greater confidence because the automated guidance responds more quickly and accurately to row deviations than human reaction times permit. The reduction in mental workload that RowSense provides becomes critically important during marathon harvest sessions that can stretch 12 to 16 hours daily when weather windows are limited and acres are plentiful. Farmers operating multiple combines can deploy less experienced operators with confidence, knowing that RowSense will prevent the costly mistakes that inexperienced drivers often make when trying to manually follow rows at high speeds. The system integrates seamlessly with John Deere's overall machine automation suite, coordinating with auto-track steering, machine speed control, and header height management to create a fully automated harvesting experience. RowSense data is logged and stored in the combine's memory systems, creating records of field passes that can be analyzed later to identify areas where guidance was challenging, potentially indicating drainage problems, compaction issues, or other agronomic concerns requiring attention. In fields where previous crop damage, disease, or wildlife have created irregular stands with missing plants, RowSense uses predictive algorithms to extrapolate row positions through gaps rather than losing guidance when sensors momentarily lose contact with stalks. The technology has proven so reliable and valuable that many farmers consider RowSense essential equipment rather than optional luxury, refusing to harvest without it. Once they've experienced the dramatic improvement in operational efficiency and grain quality it provides. Field demonstrations comparing manual steering to RowSense guided operation consistently show reductions in grain loss of 1 to 3%, improvements that translate directly to thousands of dollars in additional revenue on large farming operations. The peace of mind that RowSense provides allows operators to focus on critical decisions about machine settings, grain quality monitoring, and logistical coordination rather than spending mental energy on the repetitive task of maintaining alignment with crop rows. The C16F's LED lighting system deserves mention as more than mere convenience. Lights mounted on end divider tips serve multiple critical functions. They help prevent collisions with grain carts during on-the-go unloading, a constant risk when transferring grain while moving through dark fields. They illuminate the outer edges of the header, helping operators re-engage crop at row ends by showing exactly where the end fenders are positioned. Additional lights mounted on the header's rear illuminate stubble height, allowing operators to monitor cutting performance and adjust header height based on visual feedback rather than guessing in darkness. Night harvesting presents unique challenges, and proper lighting transforms it from dangerous guesswork into controlled operation approaching daylight conditions in safety and efficiency. The numbers tell the C16F's performance story compellingly. 7,200 bushels per hour in high-yielding dry corn represents productivity that would have seemed impossible just decades ago. To put that in perspective, a good corn yield might be 200 bushels per acre. Harvesting 7,200 bushels hourly means processing 36 acres per hour under those yield conditions, or almost 300 acres during an 8-hour day. The comparison to 12-row corn heads makes the advantage even clearer. The C16F harvests 65 more acres daily than a 12-row head, operating at the same ground speed. Over a harvest season spanning weeks, that productivity difference translates to thousands of additional acres harvested or dramatically shortened harvest windows that reduce weather risk. The economic impact compounds when considering opportunity costs. Finishing harvest earlier allows farmers to complete fall field work, secure better grain prices by timing sales strategically, and avoid the yield penalties that accumulate when corn stands in fields past optimal harvest timing. The capacity to handle corn at moisture levels exceeding 32% addresses another critical farming reality. Ideal corn harvesting occurs when grain moisture drops to 15% or lower, minimizing drying costs and maximizing grain quality. But weather doesn't always cooperate with ideal timing. Early winter storms can force farmers to harvest at higher moisture levels or risk losing crops to snow and ice. The C16F's robust gathering systems and aggressive stalk processing handle wet, heavy corn that would overwhelm less capable equipment, giving farmers flexibility to harvest when conditions demand, rather than waiting for perfect weather that may never arrive. Modern farming operations demand this kind of capacity and capability. The economics of commercial agriculture have evolved dramatically over recent decades. Successful farms have grown larger as margins compressed and economies of scale became essential for profitability. A 5,000-acre corn operation isn't unusual in the Midwest today. It's increasingly the norm rather than the exception. Those acres require harvest in narrow time windows, dictated by crop maturity, weather patterns, and the logistical realities of grain handling and storage. The C16F transforms harvest from a frantic race against time into a manageable operation where farmers can confidently predict completion dates and plan accordingly. The integration with John Deere's broader precision agriculture ecosystem amplifies the C16F's capabilities. Machine sync technology coordinates the combine with tractors pulling grain carts, automating the complex dance of on-the-go unloading. The combine operator can control both machines, maintaining optimal positioning while transferring grain at speeds approaching 10 miles per hour. This automation eliminates the stress and potential for collisions that manual unloading creates, particularly during night operations, when visibility is limited and fatigue affects judgment. Yield mapping systems track exactly how much corn comes from every square foot of every field, creating data that informs fertilizer application, hybrid selection, and agronomic decisions for subsequent growing seasons. The C16F represents more than just impressive specifications and advanced technology. It embodies a fundamental shift in how modern agriculture operates. Farming has transformed from an art passed down through generations into a data-driven science, where decisions rest on measurements, analytics, and optimization algorithms. Equipment like the C16F enables this transformation by gathering not just crops, but information. Sensors monitor everything from gathering efficiency to grain moisture to residue processing quality. That data flows into farm management systems, where it's analyzed alongside weather information, soil maps, satellite imagery, and economic projections to optimize every aspect of crop production. The C16F also reflects agriculture's ongoing evolution towards sustainability. The Romax chopping system that processes stalks into small pieces supports carbon sequestration by accelerating residue decomposition and incorporation into soil. Reduced tillage, enabled by effective residue management, conserves fuel, reduces erosion, and preserves soil structure. The precision guidance that prevents crop damage by keeping the header centered on rows eliminates unnecessary yield loss from trampling or missing ears. Every bushel harvested cleanly represents food production achieved with maximum efficiency and minimum environmental impact. Modern agriculture faces immense pressure to produce more food for growing global populations while reducing its environmental footprint. Equipment like the C16F helps square that circle by making farming simultaneously more productive and more sustainable. The C16F sits at the premium end of corn head pricing, typically commanding six-figure investments that would have seemed outrageous for harvesting equipment just a generation ago. But the economics make sense for operations with sufficient scale. The productivity gains, reduced labor requirements, operational flexibility, and yield protection that the C16F provides generate returns that justify the investment for farmers harvesting thousands of acres annually. Equipment financing allows spreading those costs across multiple years, while the machinery immediately begins generating value through improved harvesting efficiency. Looking forward, the C16F represents current technology rather than the ultimate achievement. John Deere's engineers continue developing even more advanced systems. Autonomous harvesting remains on the horizon, combines that can operate without human operators, working around the clock during optimal harvest windows. Further refinements in residue processing, grain handling, and guidance accuracy promise incremental improvements that compound into significant advantages. The integration of artificial intelligence that can adjust harvesting parameters automatically based on changing field conditions represents another frontier. But for now, the C16F stands as the embodiment of where agricultural technology has arrived, through decades of incremental innovation building toward machines that would have seemed impossible to previous generations. The story of the C16F is ultimately a story about American agriculture's relentless drive toward greater efficiency and productivity. From hand-picking corn one ear at a time to machines that harvest thousands of bushels hourly, the trajectory reflects engineering ambition meeting agricultural necessity. Modern farmers feed a nation and much of the world using fewer workers and less land than ever before. They accomplish this through technology, equipment like the C16F that multiplies human capability and transforms farming from physical labor into sophisticated machinery operation and management. The C16F folding corn head, represents the cutting edge of corn harvesting technology, a machine that embodies everything modern agriculture has become. Its folding design provides transport flexibility. Its gathering systems handle the toughest conditions. Its integration with precision agriculture platforms transforms data into decisions. Its capacity matches the most advanced combines agriculture has ever known, standing 40 feet wide when deployed, housing hundreds of engineered components, working in precise coordination, capable of harvesting more corn in 1 hour than entire farms produced in a season just a century ago. The C16F proves that agricultural equipment has reached levels of sophistication rivaling any technology humanity has developed. Have you operated a C16F or other modern folding corn heads? What amazes you most about how far harvesting equipment has evolved? Share your experiences in the comments below. We'd love to hear from farmers and operators who work with this incredible technology daily. And if you enjoyed learning about the engineering and innovation behind modern agricultural equipment, subscribe for more stories about the machines that feed America and the world. The C16F may be the current state-of-the-art, but agricultural technology never stops advancing, and the next breakthrough is already taking shape in engineering departments and research facilities where tomorrow's legendary equipment begins today.